Okay, so here we are, test one. These problems will be reviewed. This is the format of the test, but just because we don't show it in this test review, it still could show up on the test. This isn't an exhaustive list of topics that could show up on the test, but this is just a good refresher for some things to watch out for. All right, so problem number one. We've got this manometer that can measure the pressure in a tank. Just by the height of the fluid in the manometer, that can give us the pressure of the air inside. All right, so water in a tank is pressurized by air, and the pressure is measured by a multi-fluid manometer as shown in the figure. Determine the gauge pressure of the air in the tank if this H1 height is 1.2. So this is 1.2, H2 is 1.4, and H3 1.6, and they give us the densities of each of those fluids. All right, so for a pressure of a fluid in a manometer or a pressure change due to height, what do? We add rho GH if we get deeper, right? Pressure gets deeper, pressure gets larger as we go deeper, right? Y'all know that, it makes sense. But don't be careless and make sure we're thinking, I'm going to add rho GH as I go down. Where do you want to start? You could start here or here. You can start either way. Just be consistent with where you're starting. I'm going to start right over here. Generally, I like to start with the pressure that I know. I know this pressure. This is at atmospheric pressure. I don't know this pressure. That's the pressure that I'm trying to find. So I kind of leave. Start over here. I go up, down, and then I end, right? I end up at this pressure of the air. So I'd say something like P2, the pressure right here at that point, and then I go right down there, down a height of H3. I go, say that again, down a height of H3. So I'm going to add rho GH3, right? Rho of, we'll say rho 3, the mercury, right? This is mercury. Okay, it didn't matter that I went down and back up. It just matters the height I start at, the height I end up. All right, so I changed fluid, so that's why I needed to go there. Now I go from here to there. So I'm going up, so I go negative rho G. This is H2. This was the oil. All right, negative rho GH. All right. And then I go from here to here. So I'm going up, so negative rho GH1. This is the rho GH of water. All right, and then I end up at, and so that's where I put my equal sign. I end up at P1 for the air. All right, see how I did that? I started at this point. I went down, up, and then I ended at this point, right here. Okay, now, then it's just a matter of plugging things in and making sure my units work out. So this is SI units, but please look at English units. Also, this one, problem number one, it was a pressure problem. Sometimes I've just given problem number ones just unit conversion problems. Because that's how important I think units are, and that's how tricky sometimes units can be. I think it could be a whole problem in itself. It's just converting, calculating units. So anyway, be careful with the units. All right, so what is the pressure right here at P2? Well, it's open to atmospheric pressure. All right. On our conversion sheet, conversion factors, which you can use, atmospheric pressure, it's on here. It's a little bit, I don't know if it's hidden or anything, but it's on here. 1 atmosphere is atmospheric pressure. That 101.325 kPa is atmospheric pressure. I don't think we'll use anything else. Same thing right here. That is atmospheric pressure right there. All right, so we do know atmospheric pressure. That's atmospheric pressure at sea level. So let me slow down here because this is not exactly true. Atmospheric pressure is 101.325 kPa. All right, but test one review. we want to calculate the gauge pressure. We want to calculate the gauge pressure, not the absolute pressure. If it said determine the absolute pressure of air in the tank, then I would plug in the absolute pressure of atmosphere, which would be 101.325 kPa. But it asks for the gauge pressure. So the gauge pressure is just the difference from atmospheric pressure. So I set this to 0 because the gauge pressure of atmosphere is 0. So whether we're looking at gauge pressures of or atmospheric pressure, just stay consistent on both sides. If both sides ask for absolute pressure, then I would put the absolute pressure of air right here. But both sides are asking for gauge pressure, so I'm going to put the gauge pressure of air, which is 0. All right, know the difference between gauge pressure and absolute pressures. So this is 0. All right, so 0 plus rho GH. So for mercury, it just told us that the density was 13,600 kilograms per meter cube. Gravity for English, this is SI unit, sorry, 9.81 meters per second squared. And a height, H3, of 1.6 meters. All right, and so this is going to give me PA. If I just multiply those together, I've got kilograms, meters cubed per second squared, knowing that a Newton is a kilogram meter per second squared. I would end up with newtons divided by meters squared. Y'all know that a Newton per meter squared is a Pascal. So multiplying that together would just give me Pascal. Maybe I'll divide it by 1,000 to get kPa. And that's what I'm going to do. Divide it by 1,000 to get kPa. Should I just divide it by 1,000, or will y'all know when I'm going to divide it by 1,000 to get kPa? All right, minus rho GH of oil. The oil, 850 kilograms per meter cubed. Gravity, 9.81, and the height of 1.4. And then minus water. Water, its density is 1,000 kilograms per meter cubed. Now, I do expect you to know that. You could have it on your formula sheet, of course. But the density of water, 1,000 kilograms per meter cubed, that's on your formula sheet, on conversion factor. Not exactly right here. 1,000 kilograms per meter cubed, which is this, which is this, which is this. Anyway, right here, that is the density of water, 62.4 pounds per feet cubed if we're in English units. All right, SI units is pretty easy, 1,000 kilograms per meter cubed. But for English units, there it is, 62.4, or this right here. All right, but for SI units, and just, they actually told us this one, density of water is 1,000 kilograms per meters cubed. Go back and look at using specific gravity. You know, if it said that this mercury, it would have said its specific gravity is 13.6. You need to take the specific gravity times the density of water, right? The density of some other material equals the specific gravity times the density of water. So sometimes they only tell you the specific gravity. You should know the density of water, multiply times specific gravity to get the density that you're looking for. So that all was a side note because it gave it to us on a silver platter. It just said, hey, the density of water is 1,000 kilograms per meter cubed. All right, minus rho GH. I'm going minus because I'm going up. Rho of water, G of gravity, the height difference from going from the end of the oil to the end of the water. All right, and that equals P1. Sorry, P1. All right, so I would get P1 of 190.1 kPa. I probably really got 190,000, but that was PA, right? And so 190.1 kPa. So let's take a step and look back. take an overview and look back. You saw it was a manometer. Decide where you want to start from, add or subtract rho GH, and see where you end up. Now, what if I had started at P1, which would have been fine. What if I had started at P1? I would have gone down, so I would have add rho GH of the water. Then I would have gone down, so I add rho GH of the oil. Then I would have gone up, so I subtract rho GH of the mercury, and I would end up at P2. It's okay if you did that. Do you see that mathematically that is the same equation? Mathematically that is the same equation, right? You just have some of these rho GHs on the left-hand side or the right-hand side. You could rearrange, so it doesn't matter which point you start, which point you end up with. You would get the same answer. Now, you need to be careful because you're solving for that. So, through the solving process, you would add that over, subtract that over, and then you're definitely left with the same equation. All right, so rho GH, be careful with units. Be careful with gauge pressure versus absolute pressure. Specific gravity. Things like that, and I think you'll be okay. Now, so some of the most common mistakes is just adding when you should subtract, subtracting when you should add. Also, sometimes I feel like a lot of my students use the wrong H. Just look and be careful and look at where you're going from, the two locations you're going from. Make sure you use the correct H for going from the end of one to the beginning of the next. Okay, but I think that's a good refresher to get ready for problem number 1 on the test.